effect of adding a 0 to the forward path transfer function. So what is the effect of adding a 0 on the system's stability and system's bandwidth? Right? We will study in this topic. So for the prototype second order transfer function, ms is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. For this system, the forward path transfer function gs will be equal to omega n square divided by s plus zeta omega n 2 zeta omega n rather s plus 2 zeta omega n, and if I add a 0 to this forward path transfer function, then this gs will interchange as g dash s, and it can be written as omega n square divided by s plus 2 zeta omega n multiplied by 1 plus ts, 1 plus ts, right? And the m dash s becomes omega n square 1 plus ts divided by s square plus 2 zeta omega n s plus omega n square ts plus omega n square, or this will be equal to omega n square 1 plus ts divided by s square plus omega ns 2 zeta plus t omega n plus omega n square. 2 zeta plus t omega n multiplied by omega ns. This is the middle term. And if I compare this with this term, what we see that here s square, here s square, and here omega n square, here omega n square, these are same. But what is change? Here in the standard form we have 2 zeta omega n, and here we have 2 zeta plus t omega n into omega n, or 2 zeta omega n plus t omega n square. This term gives the natural frequency omega n. It means here also the natural frequency is omega n, and this term gives the damping ratio zeta. So here also the damping ratio, the modified damping ratio can be obtained from 2 zeta omega n plus T omega n square. Right? It means adding a 0 to the forward path transfer function affects zeta, affects the zeta. It doesn't affect omega n, but it affects zeta. And if zeta is affected, then resonance peak MR will also be affected, because MR is dependent only on zeta. MR is dependent only on zeta, right? So MR is affected as zeta is affected, and since MR and bandwidth are related to each other, MR is proportional to bandwidth, and therefore as zeta is affected, bandwidth will also be affected. Bandwidth will also be affected, right? So what is the general effect of adding a 0 to the forward path transfer function? The general effect of adding a 0 to the forward path transfer function is to increase the bandwidth of the closed loop system. Is to increase the bandwidth of the closed loop system, right? Now the addition of a 0 to forward path transfer function also increases the settling time also increases the settling time, but reduces rise time and the overall system becomes unstable, and the overall system becomes unstable. Means as the bandwidth increases, the system stability becomes down. Means system becomes unstable. Similarly, the addition of a pole to the forward path transfer function, adding a pole to the forward path transfer function decreases bandwidth. Adding a 0 increases the bandwidth. Adding a pole decreases the bandwidth. Adding a 0 reduces the rise time. Adding a pole increases the rise time. Increases the rise time. It also increases the resonance peak. It also increases the resonance peak and the stability of the overall system reduces. Right? If I add a 0 to the forward path transfer function, bandwidth increases. If I add a pole to the forward path transfer function, reduces the bandwidth. If I add a 0 to the forward path transfer function, it reduces the rise time, increases the settling time. If I add a if I add a pole to the forward path transfer function, it increases the rise time and reduces the settling time. The resonance peak increases with adding a pole, and it decreases with addition of a 0. But the overall system becomes unstable in both the cases. The overall system becomes unstable in both the cases. If I add a 0 or a pole to the forward path transfer function, stability reduces. Right? Stability reduces. That's why try to make smaller systems, number of smaller systems and then arrange them to make a complete stable system, right? Next topic is stability of the system by using polar plot or simply polar plot, right?